later. I just have a couple of quick administrative notes before I pass it off to our speakers. Again, this Friday webinar series, we kick it off 11:30 a.m. to 12:30 p.m. Excuse me, I gotta move my Teams window over. September 11th through October 30th, we're gonna take a break on September 25th. I got some family stuff to deal with and all that crap. Then we're gonna run it till, like I said, October 30th. And then we're gonna take a break for November, December, and January, and then pick it back up in February 2021. But don't fret, because we've got some other things planned for you. So today, we've got a presentation on Starburst Presto with a couple of people from Starburst Data. We've got Camille Badawa, and I'm slaughtering your last name, Pawlikowski, our CTO and co-founder for Starburst Data, and Zahir Gadawian, I'm sorry, I'm slaughtering your name, they'll be able to pronounce it correctly, the director of Partner Solution Architecture for Starburst Data. They'll be able to present around Starburst Presto. Then on September the 18th, we've got Jay Kamar to come in and talk about Azure governance. And we're talking about the broad slice of Azure governance. What is our security posture? What is Azure Blueprints, which is still in preview, which is a way to deploy things with a predefined compliance template. Then October 2nd, we've got Deepthi Goguri. She's going to talk about how to think like the SQL engine. And then on October 9th, we've got Choosing the Right Data Science Service for Azure by Tony McGovern. And then back on October 16th again, Jay Kumar is going to talk about Azure Security. And then we've got some other things being lined up for Friday webinars for October 23rd and October 30th. You can find all the information about where to get slides, or where, because we're recording this, where to get this video right here at meetup.com /NovaSQL. And if the speakers got their own blogs and they put their slides in their own blogs, that's generally fine. We have a YouTube channel. I've got a shortened name for that, but that's our YouTube channel. We've got videos from our past Friday webinar series, plus we've got some videos from our Azure Data Fest on, when was that, July 2nd or 3rd? We're also still working on videos from our July 30th AI/ML Fest. I think the videographer's having maybe some problems with literally the videographer's PC and its power to kind of chop up big chunks. Because we had a Proctor issue and we just decided to record whole tracks, and we're going to go chop them up later, but the chopping up piece is proven to be a challenge. Again, for all of the future events, even though you might not, for like our conferences, we ask you to RSVP via Eventbrite, you'll still be able to find out about the conference over our Meetup site. So check always meetup.com for events. Again, our weekly webinar series, September 11th through October 30th. There's also an AI/ML group. There's also a global AI/ML group. I need to get that bullet here, but they've got meetups once a month. And we're going to start putting out a targeted mini conference, which are going to be single tracks, multiple sessions, 10 a.m. to 3 p.m. We don't have those posted on Meetup yet, but we'll have them posted by Monday, where you can register and sit in on these webinars from 10 a.m. to 3 p.m. Eastern time. They'll be on Fridays, and we're going to do them in first Friday in November, first Friday in February, first Friday in April, and first Friday in June. So we'll do 4 of these mini conferences, and the first one will be on November the 6th. Oh, sorry, I was hitting the wrong button. Again, thank you for tuning in on the webinar. I'll hand it off to our speakers in just a moment, but we're always looking for talent at Microsoft. Go out to our portal, search around for jobs. If you find a job, hey, email me and we'll chat on the phone or something and get you referred. You can hit me up on Twitter at SysFrameworks. Also, you can hit the user group up at NovaSQL. And again, we try to post our user group information out there as well. And then LinkedIn. So without further ado, I'm gonna hand it off to our speakers from Starburst, Camille and Zahir. Are you guys there?
I am. This is Camille.
Yes.
Can you hear me okay?
Zahir or Camille?
Can you hear me
I
okay?
can see you talking.
Hello? Nope.
I can hear you, Camille. This is Neil.
Oh, okay, perfect.
All right, I'm here as well. Good morning, everyone. This is Zahir Gariba.
I cannot
Good morning,
hear
Zahir.
Zahir or Camille.
Hey, Tim, can you hear me?
Oh,
Both of you are unmuted.
this sounds like a problem on the other end.
Huh.
Yeah, I can hear you, Camille.
Okay.
Can you hear me? Because
Yes.
I'm not sure if. Okay, maybe it's just Tim is unable to hear us.
Looks like it.
I'm gonna leave and come back and see if I can hear you guys. I'll be right back.
But what about the other folks on the session? Can you folks hear us?
Yeah, everybody
Yeah.
can hear you, it looks like.
Yeah.
It's just Tim. So I think that Zahir and Camille, you can probably get started. Nice to meet everybody. My name's Neil. I'm also from the Starburst team. But yeah, I'd say let's get started and Tim can rejoin.
Okay. So let me share my slides so that we can go over that. Could you please let me know whether you see my slides?
Yeah.
Okay. I will go full screen, so please confirm you can see them full screen. Second. We'll go.
I can hear now. I'm sorry that I caused problem. That was me. That was all me.
All right. Do you see my slides full screen?
Yes.
Yes, I sure do. Sorry about that.
Awesome. No worries. Okay. So welcome everyone. Thank you for joining us here this Friday. We would like to. So my name is Camille. I'm co-founder, CTO of Starburst, and I will be joined by Zahir, who is senior director of partner architecture here at Starburst. We'd like to talk to you about Presto and Starburst and how we integrate into the Azure ecosystem and enable analytics across many data sources. So this will be the introduction. I will spend some time talking about one of the latest of our features, which is integration with Delta Lake, which is part of Azure Databricks. And then I will sort of position Starburst in the overall data platform architecture, and then transition to Zahir for discussion around best use cases for Starburst and a demo of the live product. So let's start with Presto. I mean, I assume not everyone here heard about Presto. So what is Presto? First of all, it's an open source project driven by the community. It was born 2012 at Facebook and born out of the need to run analytics at large scale, interactively, and potentially across many data sources that were then, reappearing at Facebook, right? So Facebook obviously was growing very fast back then. They started using Hadoop and Hive. They actually created Hive a few years before Presto, and they were just not seeing the performance and interactivity they expected out of that SQL engine, right? So they sort of invested in Presto and was started by a small group of engineers, smart engineers, who basically created this completely from scratch, taking as a blueprint classic MPP SQL data warehouse architecture. They just decided to implement this in a sort of more flexible, scalable way, and allow basically analytics at Facebook scale across many sources. So at its core, it's really MPP SQL engine, as I mentioned. So you can throw an ANSI SQL statements at Presto, and we'll just run it, using multiple machines in a cluster, anywhere from a handful to many hundreds. I believe the largest clusters are approaching around 1,000 machines per cluster, and obviously you can have multiple clusters. So they're really proven at scale, and the clear goal for Presto was to run multiple queries concurrently. I mean analytical queries, as opposed to Hive, which was really allowing you to run a few of those before they saturated Hadoop cloud. So the one very important design goal for Presto from the very beginning was separation of compute and storage. That allows, first of all, to scale those layers independently. So you can add more Presto machines, you can add more Presto clusters without really reorganizing your storage, which is, again, unlike Hadoop clusters that were tightly correlating compute nodes with storage. If you're familiar with Hadoop, and that also allows, because storage is separated, it's naturally abstracted away in a way that we can actually add not just Hadoop data, we can add object storage, or we can add relational databases and NoSQL engines like Cassandra, MongoDB, Kafka, and basically allow Presto to operate through a SQL abstraction over all those diverse data sources, and also allow you to run analytics across them, right? So you may have one table defined in MongoDB and the other table defined in object storage or Hadoop, and maybe another table defined in a relational database, and basically join them in Presto as if they were coming from a single database virtually. So this is the concept we call SQL anything, and it's really very powerful for Presto. And we'll discuss more how that enables various new use cases at scale that were not possible before. So with that, obviously Presto is just a bunch of machines. The beauty of that, because it's a compute only, you can deploy it basically anywhere. And for Facebook, that was on premises, but for Netflix, that's actually running in the cloud. The newer method of deploying is something we advocate for, is Kubernetes. That way you can be abstracted whether you run your Presto clusters were on premise or in the cloud, public or private. But really it's just a bunch of machines that on which you install software. So it could be run on bare metal if needed, right? So I will just sort of give that as an introduction to Presto in general. The key idea is, we accept SQL statement, we'll connect to the data sources behind the scenes, and we'll ship you back the answer to your analytical queries. Presto doesn't handle transactions, doesn't handle updates, deletes. That's not really the focus. This is purely sort of read-only or read-mostly analytical queries across many data sources. So with that introduction to the core of Presto, who is using this, right? I dropped several names already. Because project is around about 8 years already, there's a number of users both in the open source community as well as Starburst customers, and they typically are in several different groups, right? So you have a lot of large internet scale companies, all right? So something guys like Airbnb, LinkedIn, Lyft, Uber, Twitter, Slack, and also retail companies like so Walmart, Amazon, Overstock, and Zalando and Groupon. They all also leverage Presto for their big data lake distributed analytics. And now towards more traditional users, you'll see Netflix, Comcast, Adderall, Warner Brothers, and then because of its power and innovative use cases, it enables at scale and relatively low cost of running the analytics, it's also finding use cases in the financial sector. So FINRA is a very well-known user of Presto, and we have NASDAQ and several others in that space that are leveraging Presto for some of those use cases. So, you may be wondering, okay, so what's exactly is the type of workload you can throw at Presto, right? At the extreme scale, if you're Facebook, obviously they have it in production since day one. So we're talking about more than 10,000 nodes in aggregate, according to the latest stats they shared, thousands of users. At Uber, LinkedIn, Lyft, you're talking about hundreds of machines and hundreds of thousands of queries per day, right? So it's really used at massive scale, really high concurrency, and the data sources, those first deployments are touching are measured in petabytes, right? So this is what Presto is capable of, and that was the primary use case driven out of its origins, and now you can obviously take it to your smaller use cases as well, because it scales beautifully through the MPP architecture. So now comes Starburst, right? So what exactly is Starburst, and what's the relationship to the project? The Starburst exists actually since 2017, so not too long ago, about almost approaching 3 years now. We were born out of the need of taking Presto to the enterprises. When we first started working on this project, we were actually my previous startup was acquired by Teradata, so we ended up working on Presto there, and we basically saw enormous enterprise opportunity, and we won early customers like Comcast and FINRA and others, and we're basically convinced that there is enough opportunity for the broader enterprise market, and decided to start a separate company to tackle this opportunity. So that was 2017. A couple of years later, we were actually joined by a number of original creators and contributors to the project. So the three guys, especially who were the part of that original team at Facebook, decided to join us. So we have really the highest number of committers and expertise in Presto, and now making this available to the broader audience beyond Facebook, Twitter, Uber, etc. And when we were thinking like what's the best way to bring that capability, like there's open source projects, there's always open source, open core model where you'll be supporting your users, you'll be bringing some enhancements and enterprise features, right? So something you get out of Confluent for Kafka, out of Cloudera for Hadoop, and those examples, right? So this is what we are bringing to the table as an enterprise version of Presto, right? We bring you latest advances in performance. We allow you to connect to a number of data sources beyond what open source edition offers, and I'll be actually talking about some of those examples later. But if you want to connect to Teradata, Oracle, Delta Lake, which I'll be talking next, you can only get that in the enterprise edition. But if you are just connecting to Hadoop and Cassandra and Mongo, open source obviously covers that out of the box, right? What we found enterprises really struggling is security features and integration. So we focus on bringing role-based access control, encryption, support for encryption, masking data, and query auditing, and all those good enterprise functionality. And then on the management side, ease of deployment, configuration, auto-scaling, high availability, and monitoring. Those are all things that are expected in the enterprise settings when they cannot throw hundreds of engineers at the problem to solve it a custom way, like big companies like LinkedIn and Netflix would do. And obviously that's wrapped into the support offering, where you can have your back and 24/7, and and so provide fixes, stable releases, and patches as needed. So I mentioned one of the recent great features of Starburst is integration with Delta Lake. So if you're familiar with Azure ecosystem, there is Azure Databricks service, and Databricks, you can think of them as open source arm for the commercial arm for the open source project Spark, and they're building a very successful cloud-based platforms for Spark and AI analytics. In the past 2 years, they actually invested a lot in making your data lakes, whether that's ADLS or S3, usable in a more relational, with a more relational interface. And they proposed this format called Delta Lake. And what we like about this is, it offers asset properties over Data Lake. Again, you won't be using this for your updates, deletes as frequently as relational database, such as SQL Server. But if you do want to modify your data from time to time, this is sufficiently capable. It's an open format. It was recently open source. It's based on the Parquet files stored in the object storage under the cover, and it solves a number of problems that I guess are still a challenge for Delta lakes. So if you have a bunch of small files, Delta will take care of it, right? If your schema evolves over time, as you keep adding data to your tables, Delta will cover that. It will actually allow you to things like time travel, right? So you can look at the content of the table as of some date, maybe 5 days ago, right? So you can run experiments. What's the latest state of the database versus what was it 5 days ago or a month ago? And combined with data statistics and metadata and data skipping properties and z-ordering is very, very efficient, exceeding performance of just querying ADLS. Raw Parquet files from ADLS, right? So that additional abstraction layer comes with certain performance benefits as well. This is what we really like about Delta. So, obviously, Databricks promotes Spark as the engine for querying Delta, but really it was because of open sourcing this. There are a number of readers for other tools, right? So we decided to invest in building a native Delta reader for Presto. And why would we do that, right? So first of all, there was a way to read Delta from Presto out of the box because it taps into Hive Metastore and so it's backwards compatible via Parquet format. However, it wasn't efficient because it wasn't leveraging any of those special unique features that I mentioned in the previous slide. So we invested in building this from scratch. We support reading the Delta transaction log, understand which files are actually part of the latest snapshot. We can tap into metadata and statistics and support data skipping at the partition and the file level, and basically get you sort of all the benefits that were envisioned as part of this format, and sort of uniquely integrate that into the Presto framework, so that you can leverage those benefits immediately. So you'll be wondering what's the benefit of doing this. Obviously, it's an engineering investment. However, across a representative benchmark is at least 2x speed up on average across many queries, and some of the queries were approaching 6 times faster performance, right? And obviously, this is just a small benchmark. When we deployed this for the first time to our customers, they were really blown away because they actually saw, in many cases, more than 10x performance boost. And for them, it was a game changer because the analysts are right now able to run things in seconds rather than minutes, and that just completely changes how quickly they interact with the data and how quickly they get insights. It's no longer a coffee break query. It's something they can run interactively in front of the computer. So We definitely are sort of targeting and sort of joining the Presto and Delta Lake communities in promoting that combination as the fastest way to query your Delta Lake. So with that introduction to both of those, let me sort of go back and say, okay, how do I leverage Starburst and Presto as part of my broader data platform architecture? And I will take two angles here. So one is, okay, what is Starburst bringing on top of just Presto? And how that enables analytics, and then we'll discuss various use cases as well. So because it's a SQL engine at its core, right? When you look at this diagram from the top, you basically have the classic users, whether that's data scientist or business analyst working for marketing, finance, or any other department, right? So they will be leveraging their traditional SQL tools like BI analytics. So Microsoft Power BI or Looker or Tableau are popular among Presto consumers. If you're a data scientist, you might be leaning towards using something like Jupyter Notebook, or maybe you just want to type your SQL queries manually and leverage dbeaver or some other SQL editors out there, right? So we're really agnostic to that. You can just go via JDBC or ODBC drivers and get all those sort of classic experience for the end user. Now let's just moving to the bottom, right? Your data you want to query may be spread across many different environments and many different data stores. Right? It's common to assume that, if I get access to my relational database, this is where I need to find my insights, right? But if you do know that there's interesting data set somewhere else, maybe stored in ADLS, for example, or maybe it's in the Azure Cosmos DB or Elastic. Like if you get the power to fetch relevant data from all different sources and bring them together and correlate, and you can do that not after investing in a long ETL process that will bring all of this data into one place and integrate into a common format and invest in that long process. If you can just do that at the query time, at the analytics, during your exploratory analytics, to just like quickly take a look and figure out, is there anything interesting if I correlate those data one way, maybe another way, and a third way, and then find this magic combination that brings interesting insights. It's a very attractive, powerful tool. So this is exactly what we enable, right? So we let you query all those data sources you're seeing on this slide, right? So starting from Delta Lakes and data lakes, and all flavors, whether that's data local to Azure Cloud or remote in AWS or Google Cloud, or maybe it's on-prem. We have cases like that as well. You may have some relational data sets stored in Postgres, SQL Server, MySQL, Teradata, DB2, right? That's another sort of group of connectors we offer. And then you have all those NoSQL stores like MongoDB, Elastic, Cassandra, right? And even Kafka or Azure Event Hub, right? So now we can just bring all those together at query time. And after going through our global security mechanism, which will ensure you have access to all those sources, you have access to specific tables and columns. We'll be masking the sensitive data and encrypted traffic, etc., and then expose this to you as a SQL, basically abstraction, basically a list of tables and columns. This is how you can unlock some of those insights. One question we often get is, well, if someone has Spark and Databricks, how they use Starburst, right? Given Starburst can query also from data lakes, and now Delta format, right? So we see that there is some overlap between the tools, but it's actually not that large. And the use cases you apply to both are completely different, right? So with Azure Databricks, you'll be doing ingestion of the data, machine learning, data transformations, and manage your data lake. You can use SQL interface, but what you'll be doing with those SQL statements is completely different than in Presto, right? Presto will focus on high concurrent analytics, which is not a strong point of Spark. You'll be doing some BI reporting analytics, especially exploratory analytics when you query data lakes and federate across other sources. And sort of you're sort of accepting the fact that you won't be getting the speeds of like a traditional data warehouse, right? If someone is doing leveraging Azure Data Warehouse, Synapse, or Teradata, like that's not what Presto can offer to you, right? Those are highly optimized, curated data sets that are valuable enough for investing in sort of specialized cloud data warehouse solution, right? So Presto will give you this, exploratory analytical tool, which will be still interactive concurrent SQL, but it's not, sub-second responses out of your data warehouse to expect from those commercial offerings. And now, in terms of deploying Presto, you obviously, I mentioned you can do it in many different ways. One of the common ways, and the one we advocate for, is to deploy it into the Kubernetes cluster. So in case of Azure, that's obviously Azure Kubernetes Service, where we'll just provision a bunch of pods, and most of those machines will be acting as Presto workers, actually doing the heavy lifting, fetching data out of the data sources, and processing, filtering data, joining the data, and then aggregation happens there as well, and then ship the results back via Presto Coordinator to the end user. Presto Coordinator itself, in addition to accepting queries and planning and sort of coordinating everything, he will ensure the proper security policies are applied, the users are authenticated, and everything is sort of metadata-wise exposed to the end user for the analytical purposes. And the beauty of deploying on Kubernetes is that you can scale up and down your cluster and sort of adjust your compute needs and your spend on cloud resources to the actual needs of your users at a given moment, right? So you can start with a relatively small cluster, expand it when there's a peak of analytics use cases, maybe around lunchtime. You also scale it back a little bit and then expand again in the afternoon, and then obviously maybe reduce to a really small size overnight, right? So basically, Kubernetes with our integration on top and exposing various metrics allows you to sort of adjust the compute needs as you need, and achieving that elasticity that's very cost effective. So with that, I think I would transition to Zahir to talk a little bit about use cases that we see, various customer cases and the demonstration of the product.
Great. Thank you, Camille. So maybe we'll stick with your slides. There's only a couple of them before I jump into the demo, then I'll take the screen share. So if you, yep, thank you. So if you think about where typically Starburst can be applied to make business impact, is we play in two specific impactful use cases. If you are trying to analyze your data and want to analyze the data in an interactive manner, like in sub-second to minutes of latency and throughput, that's where we are very good fit. So if you are thinking about sub-milliseconds, then you have to have all your data in a CDW or a EDW, right? Like the traditional systems out there. But most of our use cases and customers that we run into, they are moving a lot of their data into an object store like ADLS, and they are also using Delta Lake, like Camille mentioned. So you don't want to use Spark SQL where the latencies will be too high. And if you use traditional SQL tools, it's going to be very long latencies. That's where we are very, very fast. We can run very fast queries on your data lake, where we can scale to sub-seconds and kind of then expand your use cases to where you might say, hey, I want to join data in my ADLS with my data in Delta Lake. Yes, we can do that. And we can do that across high concurrency. So that is one of our primary use cases. Now, what happens with that is typically people are trying to analyze that data with a BI dashboard like a Power BI. And what we enable there is the federation of different data sources. Rather than creating individual connections to a SQL server or a Synapse or any other databases like Teradata or Netezza, and then trying to join them all in the Power BI engine is going to be very, very slow. So what we give is a single point of access to all those different systems. And then you can write federated queries, and we can power up dashboards and run analytics very, very fast. And what we are doing with that is we are giving a lot of power to users like analysts and data stewards. You want to control who has access to what data, right? So we give you that functionality of controlling the access as well. So that ties into data governance, risk, and regulatory use cases as well. So I'll show some of that in the demo here shortly. Next slide, Camille. So if you think about this specific to the Azure ecosystem, where do we fit in? And then Camille kind of covered some of this, but typically you have your data sources in an enterprise, or a customer has a lot of data sources across their on-premises systems or in the cloud. And they are trying to stream that data. Maybe they are using Databricks, and they are going through this whole Databricks platform way of doing things, going from bronze, silver, gold, and they maybe are having a lot of changes that are happening in Delta Lake. Maybe the data is in ADLS, in blob storage. And if the use case is very specific to a batch-oriented kind of machine learning algorithmic way of analyzing data, then MLflow or any of the Azure machine learning products are the right way to go. But if you're trying to analyze that data in a more interactive fashion, then Spark SQL is not going to cut it. So that is where we are very powerful. So Starburst Enterprise Presto can not only read data from the Azure ecosystem like ADLS and Delta Lake, but also join your traditional sources of data, which could be anywhere. It could be on-prem, or it could be in other clouds. So for example, you might have data in ADLS, you might also have data in S3, right? So we could join both of them in a single SQL query, and then obviously power up dashboards like Power BI and others. Next slide. So specific to Delta Lake, what is the use case? What does it look like? So here is the flow, right? It is pretty straightforward. It is kind of a little bit of a deep dive into the previous slide. You're kind of streaming a lot of data, and then you also have hourly data, like the updates that are coming in. Delta Lake has all these functionality of merging that data into Delta tables. And once you have those Delta tables, how do you interactively analyze that data, and then also bring in like data from SQL Server, or in this case, in this illustration, we have Cosmo DB, and join all of that data and then give that access to users from either from a JDBC or an ODBC perspective to power up dashboards, or even Python scripts, or any other interactive SQL tools that are available out there. So I will be showing some of this in the demo, and the demo essentially is, if you go to the next slide, Camille. Thank you. So in the demo, what I will show you is, I'll go from the basic stuff, right? Where is Starburst Presto installed on AKS? What does that look like? And how do you configure data sources? How do you connect to data sources? And how do you create these compute clusters? I'll start there. And once we have those up and running, let's go and look at certain users, right? We'll define an admin user, and we'll also look at a user who has restricted permissions on that data sources. And then we'll connect to the cluster, and then we'll run some queries. We'll show, hey, the admin user has access to all the different data sources, the other user doesn't have access to all that, and we'll do that through different ways of role-based access control. And then I'll run a lot of federated queries just to show you that how simple it is using Starburst Presto to query Delta Lake and also ADLS, join them, connect data in Delta Lake with SQL Server, run a query between Delta Lake and Cosmo DB, and then just show you that. And then I'll also show you a Power BI dashboard that is kind of pre-built. So with that, let me share my screen here. All right. Let me know if everyone can see my screen. I am trying to show a terminal window.
I can see it.
All right, great. So I'll start at, I'm connected to my Azure environment, and I am logged into my Kubernetes cluster. So here I just ran kubectl get node. So if you're not familiar with Kubernetes, it's fine. Kubernetes is a container orchestration engine. It allows you to run different platforms in a container kind of platform. So I have 4 nodes. These are essentially virtual machines at the end of the day. And on these 4 nodes, I have already installed Starburst Presto. So if I run get pods, it will kind of show me that, hey, there is the Presto operator, which is installed. There is the Presto coordinator, which we saw in the architecture diagram. And then there is the Hive metastore for storing metadata. And then there is the worker nodes. And in this specific instance, I have 2 worker nodes, just 2. You could have hundreds or more than that, but that's how the pods will essentially spin up for that, auto scale up and down. And I also have Apache Ranger on one of the pods, which will allow me to define the fine-grained role-based access control. So with that, what I'm going to do is I'm going to go and connect to this mission control. This is like a starting point for all things Starburst Presto currently. So if I move to my mission control screen, so I am connected to that Azure environment on port 5042, which is what is mission control. And you get this dashboard which says, hey, you can create data sources and you can create clusters against those data sources. These are essentially Starburst Presto clusters. So let's go into data sources. So in this environment, I already have a bunch of data sources defined. I am connected to Cloudera CDH. I'm connected to Cosmo DB. I'm connected to a Delta Lake instance. And I'm also connected to Hive, which is essentially underneath the covers. It's connecting to ADLS Gen 2. And I'm connected to MySQL, Oracle, Postgres, SQL Server, Snowflake. I'm also connecting to S3, and so on. And if you don't see what you like here, then you can hit the plus sign, and then you can say, hey, I want to connect to Teradata. If you don't see the system that you want to connect, you can go and say, all right, let me go connect to one manually. It's as simple as that. So once you have your data sources defined, you can then go and create Starburst Enterprise clusters against it. So what does that mean? You can create multiple clusters based on your use case. Your use cases or workloads could be, I have a cluster for development, I have a cluster for testing, I have a cluster for production, or it could be I have a cluster for marketing, I have a cluster for HR and finance. It could be that kind of segregation. And typically, I have multiple here, but I have only one up and running, which is the 2 worker nodes. And if I edit this cluster, it will essentially say this cluster has access to these data sources. So those are the ones which I had shown you just now. And I can select which of those data sources this cluster has access to. It's as simple as that. So in this one, I am not connecting to Oracle. And then you go and define other things on how much RAM, CPU, how does the auto scaling work. You can do that pretty straightforward through this GUI tool. All right. So once you have the cluster defined, you can spin it up and it starts up. And it starts up in the sense it's spinning up Kubernetes pods. And that is what I showed you in the beginning through the command line. So now, once the cluster is up and running, you can go connect to the cluster overview. It's on port 8080. It's basically saying, hey, I have 2 active worker nodes. There are no queries running currently. And it will give you good information on what queries are running or coming in right in real time. So we'll go run something and you'll see things start popping up here. So this is the cluster overview. There is a lot of rich information. You can go dig in deeper, but I'll save that for now. And the next step was I wanted to show you how to define role-based access control. So we have Ranger integrated into the product that was running on one of the Kubernetes pods, and I have logged into that. And essentially, the first step is I'm going to show you some users. So I have an admin user called admin, who is like a super user who will have access to all the data sources. And then I also have this TED marketing, which is a user that belongs to the marketing group. So I'm going to go and define certain policies for this user to restrict control of what TED in marketing has access to. So the way to do that is go back and define those policies. And typically they are very straightforward. They're kind of defined here. There is this marketing policy catalogs, and it applies only to folks in marketing group and marketing interns. And if I go look at that policy, what that policy is saying is this specific policy is applicable to these different data sources. They are called catalogs: SQL Server, Snowflake, Delta Lake, Hive. And within that, all schemas should be visible. And within that, all tables should be accessible, and all columns. And this policy is applicable to this group, marketing. So as simple as that. Once I apply this, the marketing person, when he tries to access the cluster, will only see these data sources. And we can actually exclude certain columns if we wanted to. But yeah, it's very flexible in that sense. So now I have defined what data sources that person in marketing has access to. I can go and define certain masking rules as well. So I have a basic masking rule saying mask the phone number for this TED marketing person, just that user. How is that done? So the policy says for this data source, which is Hive, which is ADLS Gen 2, the schema for ADLS Gen 2, and then within that ADLS storage, you have a table called customer. In that, you have a column phone. For those phone numbers, I want to mask them. So I'm just going to mask and leave and show the last four. All right, it is as simple as that, and it applies to just this user. So with this in mind, there are some other things, like I'm also masking the entire address for that user, which will be visible. Let's connect to the cluster through a SQL tool and try to analyze this data. So I have a open source SQL tool called dbeaver, and it is pretty straightforward to connect to that cluster. All you have to do is hit, hey, I want to connect to Presto SQL. And then you just give the host name and port. The host name is essentially the coordinator host, and the port is 8080, and then you give your username. So I am going to connect using the admin user, and also I'm going to connect another session using the TED marketing user. So I have those already defined here. If I hover over this, this is essentially pointing using the JDBC driver, and the user is TED marketing. And the other one is the user is Presto_service, which essentially is the admin user. So let me expand the admin user. So if I expand the admin user, you will see every catalog or every data source that that cluster has access to. It has access to Delta Lake, CosmoDB, ADLS Gen 1, Gen 2. It has access to Snowflake, SQL Server, everything. It is as simple as that. And now if I expand the TED in marketing user, you'll see that he has access to only what we defined the policy for him as. We said he should have access to only these 5 or 6 systems. So now let's go and write some queries, right? We wanted to see the from an access perspective, does the marketing user see, I kind of ran it here, but I'm gonna move to the session where an admin user can run some queries. So I have a SQL editor open here. And I'm running this query against that table in the Hive catalog, which is pointing to ADLS Gen 2, for which I defined the role-based access policy. So if I run this, while this is running, if I switch back to the cluster overview, you will see that that query came in. It came in very fast and got executed. So it is as soon as some queries come in, this thing will start popping up and showing you real-time overviews. If I go back to the tool, yes, I got the results back because I'm just doing limit 10. I got the results. This is an admin user. He can see the phone number. He can see addresses as they are. This is some dummy data, so don't read too much into why the address is weird. But now if I switch to the session for the TED user, which is this session, and if I run a similar query on the same table, it came back fast, and you will see that the phone number is masked and only the last 4 are showing up, and the address is completely masked because we had those 2 policies defined in right here, these 2 policies. What I will do for fun is just so that you guys really believe that this is happening, and I'm going to go and change this phone number to mask the first 4 instead of the last 4. And I'm going to save that. And there is a bunch of other things here, like I'm going to show you some queries which run against Delta Lake. There is a masking rule for the Delta Lake data source on the schema, this specific schema, and this Delta Lake table, the comment column is going to be entirely masked. So you will see that when I query that for this user, marketing user. So let me go back here and I will run the same query again. So this should change the behavior of this query. There you go. It's as near real time as possible. So this is very good for data governance, use cases, risk, compliance. So you apply these rules at a global level, and you don't have to go and apply them at individual data sources. All right. Besides that, let's see what else I can do with this, right? So if I collapse the TED user and go back to the admin user, we have Cosmo DB. I can go and look at what is inside Cosmo DB. I have different schemas in here. And I think for Cosmo DB, let's see what specific the test schema. So test schema has tables, and it has the customer table and region table. I can go look at what the columns are. So this is hitting MongoDB based Cosmo DB instance. So you see the behavior. It's very simple and straightforward. And now I can write queries against this. What I want to do is I want to write a query which goes against Delta Lake and Cosmo DB, which is what I'm highlighting here. So in this specific query, I'm saying go select cust key, customer name, and some of the total price from orders from the cosmodb.test.customer table, and join that with the Delta Lake orders table on the customer key, and group by and do some things and order by. So it's as simple as that, right? So my Delta Lake is right here, and I can go into the schema which I am interested in, and I can go look at the table, and I do have an orders table there, and that is Delta orders table. So I can go and kind of access data there. So if I run this, Cosmo DB is having certain hiccups, but if I run it a couple of times, it comes back. So it gives me that result. So right now what I have done is I have ran a federated query against completely 2 different systems. And it is as simple as that with Starburst Presto. I could now do the same thing by running a federated query against Delta and ADLS. So this is what I'm doing here. I'm going select star from hive.adls.orders and customer table, where I'm joining them by a cust key, and I can just go run that. And it will run it against Delta and Hive and give me the results back. And you see that it's applying that masking policy which I have defined. So if I switch back to my cluster overview, all these queries are coming in, and they are showing up here. So those errors for Cosmo DB are also kind of popping up. So I can go and introspect what happened, but ultimately I know that there is a connection issue there. And then it will also tell you which user it was. So I'm running as Presto user, who is an admin, but if I go all the way down here, somewhere I will see TED marketing right there. All right, let me go back, run some more queries. An interesting query might be, hey, can I join data in ADLS with S3? Yes, you can. And this is as simple as that, writing that. That is possible because I have S3 connected to my Presto cluster. And then I can look at every other S3 bucket as well, and I can run queries against that. So here we are pulling in data from 2 different object stores, joining them and aggregating them and showing you results, and you're applying RBAC policies against it. So let's stop with that. I know we have 5 minutes and take some questions.
All right, anybody have any questions for Zahir or Samil? It's an excellent presentation, by the way. Oh, we do have some written questions here. Regarding ACID properties in reader-writer concurrency, how does Presto and Delta Lake compare to Snowflake? Regarding ACID properties and reader-writer concurrency, how does Presto and Data Lake compare to Snowflake?
Okay, I can tackle this one. So first of all, I believe I mentioned that Presto today doesn't do inserts, updates, deletes. I mean, you can do inserts, batch inserts, but it's not like low latency update delete situation. You can do those things via Databricks directly. So I believe it's going to be somewhat similar to Snowflake. The difference here is that Delta Lake is really an open format that sits on top of a DLS directly. You can access that with many tools, versus updates into Snowflake go into Snowflake's internal proprietary data store, right? So it's not really that accessible to the outside.
Gotcha. Thank you very much for the answer. Any other questions, guys? Does not look like there's any more questions, and that's good. Well, thank you very much, Starburst Data team, for the great presentation. And we'll get this up on the web later today for people that want to review it. And thank you very much for spending some time with us. I'm going to stop recording.
Thank you so much. Take care.
Yeah, thanks everyone. Have a good one.